Today's lesson is systems of linear inequalities. So this is the last lesson we're going to have before our test. So let's define, first of all, what a system of linear inequalities is. So two or more linear inequalities that are graphed together. Just like a system of equations, so remember before the linear inequalities, we did a system of equations, which is two or more lines that are graphed together. So something like this, right? That would be the answer to a linear equation. But our linear inequalities, they have a different solution. So a solution is an answer, right? So the answer to a system of linear inequalities, the solution is the overlapping region of points that satisfies both inequalities. So you know how we shaded for system of linear inequalities when we just graphed one of the linear inequalities last time? Now we're going to be graphing two, and we're going to be shading twice, once for each line. Wherever they both meet, wherever they overlap, right here, it says overlap, that's the answer or the solution. Okay, so for when we graphed two linear equalities, just linear equations, this was the answer, right? In this case, let's say we have one solid and one dashed line. Let's say the solid line gets shaded below, and we'll say that the dashed line gets shaded above. Where do they meet? They meet right here. That's your solution, wherever they touch. Okay? So the directions here say graph each system of linear inequalities to show all possible solutions. So I'm going to graph the first one in red. And before I graph, I'm going to decide if I have to do a solid or a dashed line and shade above or below. So let's take this equation, and I'm going to shade, actually let's see, I'm going to do a dashed line. So take a look back at your other notes if you're confused here. Dashed line because there's no equal to, it's just greater than. And because this inequality is greater than, I'm going to shade above. So now I can graph it. So I just graph it like normal, y equals mx plus b. So the -1 tells me to go down 1 on the y-axis. And my slope is -1/1. So rise -1, run +1. It's kind of hard to see, this graph paper. I'm not sure what happened to it. So that's my red line, my top line, this one right here. That's that line, but I have to do a dashed line and then I have to shade above. So I'm going to do a dashed line. And then I'm going to shade above. So this is what I would do for shading. Don't make it really, really hard with your pencil and shade as hard as you can, because the solution is going to be where they both meet, right? So I'm just going to do this. That way I know it's above, but I'm not going to shade dark until the very end. So this is the blue one I'm going to do down here. So that tells me another dashed line. But see how it's less than this time? So I'm going to shade below. Okay, y is less than x minus 5. I'm going to go down 5 on the y-axis, make a point, and then I'm going to rise 1, run 1. Rise 1, run 1. So you see how normally, if we were not graphing inequalities and we were just graphing lines, this point where they meet would be the answer, right? But that's not the case with systems of linear inequalities. Our answer is actually where they both meet in terms of shading. So that tells us that we just did a dashed line and shade below. So below is this way. Where do they meet? They meet right here. So this is your answer. So now you can shade this piece darker. Wherever both of the lines, both of the shading meet, that's our answer. And what does this even mean? This means if we choose any point in this region, doesn't matter what it is, and let's say we pick this point, whatever that point is, and we plugged it in to the top equation and the bottom equation, it would be true for both. So any point that you choose in this section, this green section, and it keeps going on, right? It goes on infinity. The graph stops here, so we just stop shading there. But any point you pick in this green region and you plug into both lines is going to be true for both equations. So that's what that means. So let's try number 2. So it says y is less than 1/3 x plus 7. So we're going to go up 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. Make a point. I'll do this one green. Okay, and then I'm going to rise 1 and run 3. Down 1 and to the left 3. Okay, and then I'm going to also say this is a dashed line. And I'm going to shade below because it's less than. So dashed line, shade below. Remember, don't shade darker until the very end. Okay, so this one I'm going to do in red, Christmas colors. We have 4, up 4, and then we're going to go down 1 to the right 1. So rise over run, or we can go up 1 to the left 1. Be really careful when you're doing your slope. I know you guys know slope, but it's still a semi-common mistake on your quizzes and tests. And I think it's just because you're not thinking about it 100%. Okay, so y is greater than or equal to negative x plus 4. The sign, we're looking at the sign, this sign greater than or equal to is a solid line this time, and it's shade above. Okay, so solid. And make sure you go all the way for your graph, especially because we're shading now. And we don't want to just like draw a short little line. Make sure to go all the way from one side of the graph to the other. So wherever they meet is your answer. They meet here, so this whole thing shade darker. So this is your answer. So any point that we pick in that purple region, if we plugged it into both the top and bottom equation, it would be true for both. That's what that means. Okay, let's try number 3. So the top equation. Now remember, we can't graph like this. We have to get it into y equals mx plus b. So x minus 4y is less than or equal to 24. The first step, we always subtract x. Negative 4y is less than or equal to negative x plus 24. My last step is to divide. Now, remember, when we divide by a negative, I'm going to do this in a different color. When we divide by a negative, we have to flip this sign. So because we divided by a negative, we have, this cancels. We have y, and then this sign right here flips, is greater than or equal to. Now, this sign, negative x over negative 4, is a positive 1 over 4 x. 24 divided by negative 4 is negative 6. So that's one of your equations. I'm going to graph this in green. So I'm going to go down 6 on my y-axis, and then I'm going to rise 1, run 4, and then I can also go down 1 to the left 4. And then I have to figure out, this tells me it's solid and shade above. Use your notes from last time to figure that out. Let's see if I can draw this straight line. Yeah, that's okay. Okay, shade above, so all this section, all this area. Okay, now we have to look at the next equation, but the next equation is already in y equals mx plus b, so I'm just going to write it over here because I don't really have room below. That tells me solid line and shade below because it's less than, and it's solid because of that equal to sign. So we're going to rise 1, and then we're going to go up 1 on the y-axis because of this 1, and then we're going to rise 2, run 1, rise 2, run 1, down 2 to the left 1. Okay, so this is solid line, So I'm going to draw a solid line, and it says shade below, so I'm going to shade this way, below the line. Where do the two meet? In this big section right here, this is where the shading of the two lines meet. So that's our answer. So always shade that darker so I know on your test or quiz that this is the right answer. Okay. Let's try number 4. And then I'll have you guys try a couple. So number 4, x is less than -4. Okay, so let's do that one in red. Oops, let's do that one in red. And remember, x is -4 is, I don't know why this is so hard to see. It didn't print out right. Somewhere over here. We'll say that's x is -4. So let me go 1, 2, 3, 4. Okay, so that's x is -4. So we have to figure out this sign, because of that less than, we're going to shade, well, it's going to be a dashed line. And we're going to shade below because it's less than. Okay, so first of all, since it's an x, remember x is just a vertical line. So that's an x equals less than -4 line. But now we need to shade below. Now there's no way to shade below because we're not going to, don't draw this, but we're not going to draw here, right? It crosses that line. So think about it this way. Is this, do you think this would be less than? Like, is this going in a negative direction for x, or is this going in a negative direction for x? Well, if we're shading below, we should go in a negative direction, right? So shading below, you can also shade to the left. So we're going to shade to the left because all of this area over here is where the x is getting smaller. It's just the x continues to get smaller, right? So shade below could also be shade to the left. If it's the only time it would be shade left is if it was just a vertical line like this. Okay, now the bottom equation, we have to get y alone. So 3x plus 2y is less than or equal to -2. We're going to subtract 3x from both sides first. And we're going to have 2y is less than or equal to -3x minus 2. We're dividing this time by a +2, so we do not flip the sign. So y is less than or equal to, that stays the same because we divided by a positive. -3 over 2x minus 1. So go down 1 on the y-axis, and then rise -3, run +2, or rise +3, run -2. And then this right here, that sign tells us to shade below, and it's a solid line. So solid line, and then shade below, so this way. So you see how the red and the blue, they meet in this area right here. So this whole green area is our answer. All right. Let's see, I want you guys to try 5 and 6. Wow, this is a lot. Let me see. 5 and 6, we'll try 8. You don't have to worry about, we'll do 7 and 8. And 9. Okay, 7, 8, 9. So you don't have to worry about 10, 11, or 12. Okay, let's try an application. See what a word problem looks like for this. So it says Sarah's pet store never has more than a combined total of 16 cats and dogs. She also never has more than 9 cats. Write a system of inequalities and graph to show the possible number of cats and dogs in her store. So when we have word problems, we always want to define our variable. So I'm going to say let x equal the number of cats and let y equal the number of dogs. Then let's write an equation. So Sarah's pet store never has more than a combined total of 16 cats and dogs. So a combined total, when you're combining cats and dogs, we're going to add, right? So cats plus dogs is never going to be more than 16. What sign are we going to use in between here? Cats plus dogs, right? X plus y, cats plus dogs, is never more than 16. So if it's never more than, that means it's always going to be less than or equal to, right? So it could be equal to 16, it could be less than 16, but it's never going to be more than 16. Okay? And then it also says she also never has more than 9 cats. So here's cats, cats is X. She never has more than that. So it's always going to be less than or equal to because she never has more than 9. So now we can graph these two. All right, so the first step, let's subtract X. So this equation is y is less than or equal to negative x plus 16. Remember, we don't flip the sign because we're just subtracting x from both sides to get y alone. The way we graph is always to get y by itself, but we're subtracting x. We're not dividing by anything or multiplying. So we don't flip the sign stays the same. And then we have this equation, x is less than or equal to 9. So let's graph this one. This is going to be a solid line, solid A. Solid and shade below. So solid and shade below. Okay, let's count 16 here. So first of all, we have to go up 16 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, right here. Okay, so right there, this is 16. And then it says to go down one to the right one. So our slope is down one to the right one. And just because this is such a long line, because we're going all the way just clear to the other side of the graph, I'm just going to keep drawing dots here. And it said, I said solid, right? Solid, and then we're going to shade below. Solid and shade below. So it's going to be all the way over here. Okay, and then x is less than or equal to 9. That sign means solid and shade below. Remember, we graph x equals 9 in the same way we graph x is less than or equal to 9, except we need a shade. So we're going to go on the x-axis and count over 9. 5, 6, 7, 8, 9. We're going to make a point right there. And then we're going to draw a solid line. Remember, an x equals is always a vertical line. Okay, and we're going to shade below. And remember, when it's shade below, we're going to shade where x is getting smaller. So x gets smaller and smaller the farther we go this way, right? So that means we're going to shade this way. If it was x is greater than or equal to 9, it would be this way because x gets greater that way. So we're going to shade here. Where do they meet? They meet here. So all of this is your answer. So that means any one of those points is going to satisfy or going to be true for both equations. So it doesn't matter if you plugged it into this equation or this equation. If you plug in any point in this green region, it's going to be true for both equations. So this is all of the possible number of cats and dogs in her store. Okay, so try numbers 7, 8, and 9. 5, 6, 7, 8, 9. Okay, and see how you do. And then come and check with me.